Okay, I want to take a look at interval notation and some inequalities and how we write the solutions to those inequalities using interval notation. We're going to start off with some very simple inequalities and look at how we graph the solution on the number line than -2. Now I would always recommend that you put 0 on your number line and you put the other key numbers from your inequality. We only have one, that's -2. We want to include everything less than -2. We know as we move to the left on the number line, the value of the numbers is less. So we're going to be shading to the left. You may have had a class before where you used an open circle to show that -2 was not included because we do not have an equal sign. And then you shaded everything to the left. We're going to change that a little bit. That is a valid way of representing this, but we're going to use a different approach because we want to be able to write the solution in interval notation, so we're going to tie our graph to that. You'll use interval notation in this class and in future classes. And the only difference is, instead of an open circle or a closed circle, we're going to use parentheses or a bracket. Okay? So we're still going to think about what's our key number. It's -2. We're looking for everything less than, and we're not including that. We're going to put a parenthesis on -2. We're going to show that parenthesis opening in the direction that we're going to shade. So it's going to open to the left because we're shading everything to the left to show that it's less than. Now we can look at our graph and write this in what we call interval notation. An interval notation represents an interval of numbers from a low point to a high point. Okay? We look at this graph and we say, what's our lowest number? We don't have a lowest number. It's continuing on. That arrow says it goes on to -infinity. Okay? So we're going to put -infinity. Or it looks kind of like a sideways 8 symbol. And we're going up to -2. We're going to put that same parenthesis that we had on the -2 beside it to indicate that -2 is not included. We're going to always have parentheses if we've got -infinity or positive infinity because there is no last number to include or exclude. So my interval is everything from -infinity up to but not including -2. And I can tell that because of the parentheses. Okay, next we'll take a look at x is greater than or equal to 1. On our number line, we need to show 0 and +1. Think about which direction we're going to shade. We're looking for values of x that are greater than or equal to 1. So greater than means we go to the right. We're including the 1 because we have an equal sign. So this time we're going to use a bracket, and that bracket's going to open to the right because we're going to shade to the right. To write that in interval notation, we think about what's our lowest number. Our lowest number is 1. It's included. So we put a bracket to the left of that. We're going up to +infinity because we don't have an end. Whether it's positive infinity or -infinity, it always has parentheses beside it. With an interval notation, we always go from the lowest to the highest. And that describes our interval. We read that as the interval from +1, including 1, up to +infinity. Alright, let's take a look at one that's a little different. If we look at something that's -4 is less than or equal to x, which is less than 0. Now we have a closed interval. We do have a lowest number. We do have a highest number. We're not going to infinity on either end. We're looking for values of x that are between -4 and 0, including -4, but not including 0. If I do that on a number line, I think about my key numbers, -4, 0. I know that I'm looking for values of x that are between those two, so I know I'm going to be shading in the middle. But now what I have to think about is, am I including -4 Yes, so I know I'm going to use a bracket. I know I'm including it because it had an equal sign. The bracket's going to open to the right because our interval is between those two numbers. We're going to shade to the right. On 0, I'm not including 0, so I'm going to have parentheses. I'm going to open to the left because now I'm going to be shading to the left because I'm only looking at numbers between those two. My interval is from -4 to 0. I think about what's on the number. I had a bracket on -4, so I put a bracket beside it. I had parentheses on 0, so I put parentheses beside it. It's the interval from -4 to 0, including -4, excluding 0. Alright, next let's talk about solving inequalities. This looks similar to equations that we've solved. And we do a lot of things exactly the same way. There's one big difference. When we divide an inequality by a negative sign or a negative number, then we have to reverse the inequality symbol. And before we start this problem, let's think about why that's true. Okay, in this case, that's not going to apply. We're not going to have a negative coefficient. But let's talk about why that does apply. If we have 4 is less than 6, we know that's a true statement. 4 is less than 6. If we multiply both sides by 2, we get 8 is less than 12. That's still a true statement. If we divide by a negative, let's say -1, we get -8 is less than -12. That's not a true statement. -12 is further left on the number line than -8. So -12 is less than -8. When we divide by a negative, it reverses the sense of the inequality. So we have to reverse the symbol. And less than becomes greater than. So that only happens when we divide both sides by a negative. Any other time we're solving just like we solve an equation. One thing that I would recommend is that with inequalities you always take variables to the left side, because with an inequality we read from the variable and we're used to reading left to right. So let's solve this one. We're going to distribute the 4. We're going to get 8y minus 12 is less than -28. We've only got one variable term. It's on the left side already. We're going to leave it there. We're going to add 12 to both sides to get 8y is less than -16. We're going to divide by +8, and we get y is less than -2. Okay, now that's a negative number that's in our solution. That's not a negative coefficient. We divided by +8, so we don't start switching any symbols there. That's our solution. If we think about graphing that on a number line, on our number line we would have -2 and 0. We would show everything less than -2 but not including -2. So we'd have parentheses on -2 opening to the left, and we would shade to the left. We have 8 minus 2y is less than 12. Okay, we are going to start by subtracting 8 to get the variable term by itself on the left side of the inequality. 8 minus 8 gives me 0. I'm left with -2y is less than 12 minus 8 gives me 4. I divide by -2. And I get positive y. Don't change your division rules. Division rules are exactly the same as they've been before. Less than becomes greater than. 4 divided by -2 gives me -2. So my solution is everything greater than -2. So I put parentheses opening to the right, and I shade to the right because it's greater. Interval notation, my lowest number is -2. It has parentheses because we had parentheses on the graph because we did not have an equal sign. My highest number, I go all the way up to infinity.